So what do you think? One person says a car is traveling at 10 kilometers per hour, while another states it's traveling at 90 kilometers per hour. Both of them are correct. How can this occur?
Everyone thought that was Questions invalid.
Depends on how fast those people are going.
It depends on how fast they're going. So if they're traveling, if one of them is traveling at 50 or 80 kilometers per hour and someone passes them 10 miles per hour faster than them, they're going to say that they're only moving 10 miles per hour, but that person would be going 90 miles per hour, or kilometers per hour.
No, I'm pretty sure if I'm going 55 down the road, it's my time.
Yes, and someone passes you. No, someone passes you.
No, passes you. You're going to know they're going faster than you.
Yeah. Well, no, they are going only 10 in relation to you. Relative to you, they're moving 10 miles per hour.
I understand that.
Well, relative to you. Right. Yeah, or 80 to 90. Yep, so they're...
I don't understand this example. What's the example?
You're going 80 miles an hour. A car passes you. How fast is the car going relative to you?
relative to you. If it's going 90 miles per hour.
And I'm going 80?
Yep. Yes. Yep.
Still, how fast is that car?
90.
And if you're in that car, how fast is that car going?
0.
Yes.
Yeah. Learn something so if I get pulled over...
No, it's relative to the cop car. If you get pulled over, it's relative to the cop car.
He's driving and changes that.
So if you're driving like this, you're actually on the highway. You're actually going 120 miles an hour.
So the speed that was 120.
You try that. You try that with him and see what he says.
Like, that's pretty funny.
I'll call you.
Yes, Dylan.
Nope, I physically
So if you're in a car, if the car's not going 0 because you're in it, and you're going,
No, relative to you,
You're supposed to love this stuff.
relative to you, the car is going 0. If you're sitting in the car driving 55 miles per hour.
so the world is flying by 60 miles.
Yes, relative to you.
So if I try that, can I call you and be like, hey, my physics teacher...
No.
Well, it's stupid. I can see why you're saying stupid because I get it. But if you're saying that, I get it.
So, velocity changes based on your frame of reference. So, okay, I don't have a tennis ball, but I have a ball. Okay, according to me,
That's all physics is.
I'm going to drop this ball. Okay, so if I drop it, it comes straight down, straight down, right? According to me, I'm just going to drop it straight down. You tell me what the ball does, according to you.
Oh, it just goes straight down, straight up. Well,
It was-
With you, I saw it.
It's like inertia. Wait, do it again. Just stay there.
Okay, I
Okay.
dropped. Okay,
Like this. Oh, and now it wants forward.
It goes like this.
and it goes forward because it still lands by my foot, right? When I drop it. So my speed gets transferred to the ball.
Yes, except it has air resistance. Yeah. We're not in the
Right.
Okay, so what are we trying to get at here?
Well, we have does it still count on the second bounce though?
Well, we're not talking about after the bounce.
bounce and
Ball's point of view, it's just going straight down.
But from my point of view, I dropped it down and it landed right by my foot. It dropped straight down.
Keller! Shut up. Leave. I don't want to hear anything.
Bunny goes over there.
So it depends on your frame of reference. Let's see what this says.
Yes,
When you measure the velocity of an object, your results depend on your own motion as well as the motion of the object. Imagine a plane flying overhead, dropping a crate. If you are standing on the ground, the crate will be seen to move sideways at the plane's velocity while falling down. However, if you measure the crate's motion from the airplane, it does not move forwards or backwards from your point of view. The crate falls straight down in this frame of reference. To really understand this, Pretend that you are in a completely vibration and wind-free airplane. You might have no idea you are moving if there was nothing nearby to compare your motion with. No frame of reference is special or preferred over any other. Therefore, all motion is relative. When you measure an object's velocity, you are really measuring its velocity compared to your own. All motion is relative.
So how would bombers know that they're bombing, now?
We have to take that into account.
Like back in that?
You still have to take that into account.
Like blows up, like,
Yep.
bad under me, how bad it is.
Like the nuke that wasn't supposed to hit Nagasaki. And they miscalculated.
He's like over his head.
So here, this is just showing the 2 frames of reference. So this would be from the frame of, if you're in the plane and you drop the crate, it's just going straight down because it's going the same, at the same vertical speed or horizontal speed. It has the same horizontal speed. But according to someone on the ground, it would look like, it just looks like horizontal or projectile motion, right?
Yep.
So it's a, yep. Yes, we just talked about that. So if we look at the VAC means the velocity of object A with respect to frame reference C.
Frame reference is plane or what?
Well, it'll be. We'll just go over some examples here. We'll be able to see what that means a little better. I think it's easier than writing all those little subscripts. Yeah.
Wait, so is the A the object? C is point frame of reference.
So if you want to know the whole velocity, you're basically going to take the frame of reference, the velocity based on one frame of reference, and if in their opposite directions, you're subtracting them. If they're in the same direction, you're going to add them.
So B is just another object, right?
Plane's going a certain distance, and then like let's go like 100 meters just add that.
Mm-hmm.
Is B just like another object?
Yes, B would be another object. So a boat traveling downstream, the speed of the boat, is with respect to Earth. So BE, so the speed of the boat with respect to Earth is 20 kilometers per hour. The speed of the river with respect to the Earth, so river to the Earth, is 5 kilometers per hour. What's the speed of the boat
25 or 15?
with respect to the river?
Oh, 15.
Yeah, you can't just.
Well, just think if they're both going in the same direction, right? Because if they were opposite directions, it would be one would be positive, one would be negative.
No, so it's 15.
Wait,
It's well positive, so it's 25.
It's 15.
Because it's going 20 with Earth, but it's got an extra 5 with the river.
think about it. The
No,
river's
it's
going
plus
this way.
It is true. It is going 15. See, I was right. First time.
Why do they have?
Boom.
It's 15. Why? Because it's the same.
Why
as the car.
negative though?
It's the same as the car.
Yeah.
The same way. It's like this.
Since it's already got the 20, it can't use the same side.
Oh, okay, yeah.
Yeah. See?
When you add it, if it's going downstream, it's going with the stream.
Perspective, like if you're standing on shore.
Okay. Remember when they said the car was responsible?
Okay, yeah, because.
Wait, no,
So
no,
you're
no.
standing on shore.
Right.
Say it
So you're standing on the shore and it's going 20.
So you're taking out.
That's what it's saying.
But
With
the
respect
river's
to
also
Earth.
going 5, so it's already like it's got a 5 with the 20. So
So you're taking that out to get.
you got to take the
actual
5
boat.
out to get the actual
And then
boat.
it's asking, like, if
Yes.
you're standing on it,
Confusing,
do
but
this
somehow
one.
I got
No,
it.
the actual boat
That
size
is
is
I got the
20.
Yeah, we got this. We
The
get
speed of the boat with respect to the river is a 15.
So the boat is not going to fit 20. It's if you are
It's going 15 with the 5, so it's 20.
right. So it's saying if you're on. Can I just talk?
Motion is.
Okay.
You said it's going 15. I said that. Maybe.
Okay. If you're standing on the Earth, the boat looks like it's going 20. So it's respect to the Earth. But if you are if you're on Earth, you look like the river. If you're looking at just the river, is going 5. So that means the boat has to be going 15 in order for it to look like it's going 20. In order for it, it's kind of backwards. So you are you see it as going 20, but the boat is actually only going 15 because 5 miles per hour or kilometers per hour is part of that 20.
Chase, we got a 50-50 shot.
The river is pushing it along 5 kilometers per hour faster, so the boat on the river is actually only going
It
15.
makes sense, Remington. It makes total sense.
Yeah, think about it. Okay.
Who's confused?
Standing on the earth.
Wow, that's awesome. 'Cause I'm
Right, if the river was motionless, it would be 15. If it was on a pond, but since the river is pushing it 5 more.
It's so high tech up there that it's like
Looks like.
some
It's all about what
smart people know so much that they get confused.
The boat's going 20.
Because all the smart people know is that there's an equation behind everything. See, we're so dumb. We don't get the equation. This stuff makes sense.
I'm talking about what it looks like it's going.
That makes sense. That's why.
But it's going 20. Love it.
Compared to
That's
that.
with
It's like this pedometer says
Why you take it
To get
But the boat is moving at a
Okay,
rate
another
of
one,
20
another one, another one.
kilometers per hour.
Okay, a plane flies northeast at an airspeed of 563 kilometers per hour. So that is relative to the air. So if you were somehow suspended in the air, you would see this plane going past you at 563 kilometers per hour. A 48 kilometer per hour wind is blowing to the southeast.
Wait. We're going this way, the wind's blowing this way.
Is this vector time?
No.
We're going northeast. Boom. So we got a 90-degree angle.
We're going northeast and it's blowing
Oops.
southeast. So
Whoa, that was weird. Added.
So if we're going northeast,
7th grade volleyball team may be dismissed.
Let's see if we can draw this one out. 563 kilometers per hour. I'm going to use black since everyone's in here is black.
Orange. I said orange first.
She said left. She's already wearing orange. We're black.
Seniors are blind.
Yeah.
And then, what was the other one?
48.
Southeast, though.
Southeast, yes.
So it's going against the grain. This is vector.
So really, we're looking for this.
Wait a minute.
That's a 9.
So you subtract 48 then.
No, and then you have to do PTAG time, because it's a right triangle.
Is that a right triangle?
Yeah, because southeast and northeast,
Yeah,
that's a 9.
that should be
And
90.
then how do you know? Okay, yeah. Still.
But we don't know. We only know one of them.
Yeah, we only have 48 miles
The
an hour.
wind is 48.
yeah, so if the wind's...
Oh, this was what?
48.
Oh, okay. Yep.
No one calls it PTAG. It's PTAG time.
PTAG up.
So what do you get when you use that Pythagorean theorem?
You get 48 squared plus b squared equals 563 squared.
Squared, and then you take
Squared.
the root of that answer. You get 565.
Yeah.
Oh, it's 40.1
Yes. You're looking for hypotenuse.
degrees. Uh-oh. Uh-oh.
Yeah, you gotta use the cosine.
A squared plus B squared.
No, you can't use a squared plus b squared because that angle is a 40-degree point. 40 that's the angle like down in the small angle right there. Yeah, so that wouldn't be a 30, 60, 90 though. He said it's 30, 60, 90.
You just have to have a
Yeah, it is. Because this is northeast, this is a 45, and then this would be a 45. So
Go
this,
back, it says 40.1 degrees.
that would be the answer. Now we are looking for, we need to find this angle right here.
What? Wait, why? Why do you have to say that?
Tangent tone.
It's a vector.
I
Yep.
don't get what that means.
You gotta know the northeast.
Yeah, what angle north of east are we at? So we would use tangent
Tangent tone.
Wait, how?
to get, we're going to end up getting this angle then.
Inverse tangent.
Equal.
48 over 560.
That's like 4.87.
So what'd you get?
I got 4.7.
4.87 degrees. So, but we want this angle, so take,
So it's 45 minus.
yep, 45 minus 4.87.
40.13.
Okay, what was your question, Chase?
Why do you have to take that other angle?
This one?
No,
But-
I
I found that one.
We found this one. Do you know why? Because this isn't relation to anything. Like, we want it to relation to north and east. I know. So that's this angle. This angle is a 4.87 degree angle. But that's not relation to any of our axes. So in relation to our axes, we want this angle.
So this is on an axis, correct?
Yeah, if you kind of...
Y and the X.
Yeah.
Okay. That makes sense.
Okay.
It's kind of like you're showing a right shaft. Oh.
Any other questions? Yep. Because this was straight northeast, so we know from here to here, all the way here is 45. Yep, and so this little bit is 4, so added together they have to equal 45. Because it just said northeast. Yeah, so yeah, if they don't give an actual angle, it's... We calculated the 4 is this one up here.
Up here?
Yeah, right there. Yeah, and so that's why we took 45 minus that little one, and that gave us the 40.
So we find the one in the triangle.
Right. Yes, yes.
I got you now.
So how would the pilot need to adjust the direction to maintain heading straight northeast? You'd have to overcorrect a little bit to the left, right? By the 4 point whatever degree. Yeah. Mm-hmm. So now we understand this one, right?
Yes.
So how fast is it going relative to your frame of reference? Suppose you're traveling. You are traveling at 80 kilometers per hour when a car passes you. And it is going to go 10 because it's going 10 miles per hour fast or kilometers per hour faster.
It's moving at
How fast is it moving relative to Earth?
90.
90.
Then how fast should it be if you were in there? Does velocity always?
Does velocity always depend on the frame of reference? Yes. Does acceleration depend on frame of reference? No. Okay.
Oh crap.
No, it's ours.
Is the river going east or north? I forget. The river's going east. So let's draw the... And it's going how fast east?
95.
And you're trying to go north? Was that?
The river from the south.
Wait, why did I put 5?
We're going... No, the motorboat's going east.
Yep.
And the river flows north at 9.
Oh, so we're not doing 43.
No, we're doing this one.
Then I gave you false information.
Okay.
Motorboat is going 16 north at 9.
We're going this way, we're going this way.
Whoops.
Oh, ford the river. You never ford the river.
You always ford it. What is the, which one?
Yeah, right.
No, for what?
I love that.
So what's your actual velocity? It's going to be, you need to find right here.
Squared plus 16 squared equals whatever squared.
Yes. So use 16 meters per second and 9 meters per second. So you're going to use 16 squared plus 9 squared is equal to c squared.
All right, so then we get that side. 3 squared squared plus another something.
So,
4 squared squared.
relative to the Earth. Yep.
4 squared squared. That's just 16 squared. Which one is 18?
And then you will need to find this angle also. So then you're going to use
16 squared, isn't like 232?
opposite over adjacent. What was it?
16 times 16 is 232.
Okay, now the next question. So that would be how fast it is relative to the Earth.
What did we do with the 18.4? Did we do anything with that?
That is this.
That's that side. Okay, and then we found the tangent of it.
So that would be theta.
But where's our coordinate plane at? Or do we not have the coordinate plane?
Like here would be x.
Okay.
Like that?
You mean y and x.
Yeah, y and x, yeah. So then the next question says, if the river is 136 meters wide, how long does it take the motorboat to reach the other side? We're going to have to draw a similar triangle because we didn't actually travel the 136 kilometers, did we? Or meters? Was it 100? Yeah, do you have that? Because did we travel straight across the river? No, we're traveling at this angle. So,
We need to quit doing boats and water and planes in the air. Let's just do cars. Then they'll go this way or this
okay, but this theta, all of our ratios should be the same. So our theta should be the same. We have 29.4 degrees. So we need to find this distance. What distance did we actually travel? 136, that they gave us that. Yeah. So the 136, they said the river is 136 meters wide. Yeah, so what would we use? We'd use cosine? Cosine of 29.4 is over x. We're looking for that.
What's cosine again?
Adjacent over hypotenuse. No, because it asks for how long.
And then you multiply by 136, correct?
Yep. So this is our distance that we traveled. Yeah, what is that? 156? Okay, so that's our actual distance we travel. And I think the question asks for how long. So we need time. So now we know the velocity that we traveled. We know the distance that we traveled. What's our equation we're going to use? Because we're not accelerating, we're moving at a constant velocity. So we would have t is equal to, what's our x? 156.1 all over 18.4. And what's that? Time. 18.4. There you go. That would be time. And then how far downstream is the boat? That would be this component right here. So if you could find that, we should be able to find that. How far the boat is downstream would be this.
Now, wait.
Yeah, you do tangent, yeah. It'd be tangent of 129. Or, yeah. So it'd be x over 136. Now, I don't know if that's how you would solve them. I don't know if they're asking for time and how far down the stream, but you got to do something similar to this to find for 43. Mm-hmm.